Hello, today we are going to be talking about solving quadratic equations by completing the square. So, a square, in this instance, what we're talking about, is making the first two terms, or rather the left side, a perfect square trinomial. So, an example of a perfect square trinomial would be x squared plus 10x plus 25. And the reason being is because two numbers that multiply to 25 that also add to 10 are 5 and 5. So our factors are identical, which means this can be rewritten as x plus 5 squared. So our original is a perfect square trinomial. So that is what we are trying to make happen when we are completing the square. So if we check here, 8 divided by 2 is 4, 4 squared is 16. That is not the number I have, so I'm going to force that into my equation. So, if I add 10 to both sides, just because I want to get C, or the product, or the constant, in this instance, over to the right side, I'm going to add 10 to both sides. Now, I want to make sure I accommodate a space for the number I'm going to force into my equation. Now, of course, if I'm going to force a number into my equation on the left, I have to force the same number in on the right. So that's why I'm adding left and right. That's also the addition property of equality. So now I'm going to take 8 divided by 2 to get 4, which is positive, and square it to get 16, and that is the number I will force on both sides. So I can double check this. Two numbers that multiply to 16 that also add to 8 is 4 and 4. So now that I've done this, I need to factor my trinomial on the right side. So if I factor this, like we just said, two numbers that multiply to 16 and also add to 8 are 4 and 4. So I can go straight into this format of our equation. So this is going to be parentheses x plus 4 parentheses squared, right? So it turns out that this number, when we divide it by 2, is the number that goes in your parentheses for the factor. And now we have to accommodate for our adjustment number on the right side. So when I added that 16, I had to adjust the right side of the equation. So 10 plus 16 is 26. This is actually called our intermediate step. It's an equivalent equation to our original and is the step in between before I continue the process of solving. So this is often asked on the Regents exam, where they say what is an intermediate step, and they give you the original equation here. And they'll give you 4 choices of any versions that look similar to this. So it's very important you understand that this is an intermediate step, and that's the definition for it. So now, how are we going to continue solving? I'm just going to rewrite it as to not interfere with our intermediate step. We need to use inverse operations. So x plus 4 is being squared, so I will take the square roots of both sides. So I'm going to get x plus 4 equals plus or minus the square root of 26. And now I'm going to have minus 4 on both sides, which I'm going to place right in front of that plus or minus. This should look familiar. This should look very similar to the quadratic formula. Okay, the quadratic formula has that plus or minus symbol because all radicals actually have a positive and negative version. So this is our final answer. The square root of 26 cannot be simplified. So if you'd like to get a head start at number 2, by all means. All right, so for number 2, once again, I'm going to add 15 to both sides. X squared minus 6x. Leave yourself some space to add a number on both sides. So I'm going to take negative 6 divided by 2 to get negative 3. Place it in parentheses to square it to get a positive 9, and that's what I add to both sides. Once again, two numbers that multiply to 9 that also add to a negative 6 are negative 3 and negative 3. So if this is going to be x minus 3 times x minus 3, I can just rewrite it as x minus 3 squared. And of course, on the right side, I'm going to wind up with 24. Okay, so this was our perfect square trinomial that factored into x minus 3 squared. The right side is the adjustment that I needed to make to my equation. And now we've arrived at our intermediate step. So I'm going to continue solving. X minus 3 squared equals 24 can be solved by taking the square root of both sides. I'm left with x minus 3 equals plus or minus the square root of 24. And add 3 to both sides. I'm left with x equals 3 plus or minus the square root of 24. So 24 is actually a radical that can be simplified. Okay, I actually will be posting a video on how to simplify radicals soon. But just so you know, 24, if I list the factors of 24, are as follows. None of these are perfect squares until I get to 4. So if I determine that radical 4 times radical 6, which is the same thing as radical 24, radical 4 actually reduces to the whole number 2. So I can simplify this a little bit further as 3 plus or minus 2 square roots of 6. Okay, both of these are equivalents. Okay, just depends on how simplified you want to get your answer. If I type 3 plus the square root of 24 in the calculator, I will get the same decimal as 3 plus 2 square roots of 6 in the graphing calculator. All right, if you would like to try 3 and 4 on your own, by all means. You'll notice in these two examples, our constant is already on the right side of our equation. So we do not need to subtract it to bring it here and then add it to bring it back. I can instead just set myself up with a little bit of room here and determine what needs to be added to both sides to create a perfect square trinomial on the left. So I'm going to take 10 divided by 2 to get 5, square it to get 25. That's our original example up here. So this factored is x plus 5 squared, right? That's our perfect square trinomial and its factored form. And then on the right, 8 plus 25 winds up being 33. And that was the right side. So our intermediate step is as follows, and we're going to continue by solving. So x plus 5 squared equals 33. Take the square root of both sides to be left with x plus 5 equals plus or minus the square root of 33. Then we subtract 5 from both sides, squeeze that right in front on the right side here, and that's what x is equal to. These are our solutions. All right, and last but not least, once again, I'm going to take x squared plus 4x plus a number is equal to 2 plus something on the other side. 4 divided by 2 is 2. 2 squared is 4. So I add 4 to both sides. Once again, two numbers that multiply to 4 that also add to 4 is 2. That's what I have right here. So x plus 2 squared equals 4 plus 2 is 6. That is our intermediate step. And from here, I'm going to continue solving by using inverse operations. So I take the square root of both sides. X plus 2 equals plus or minus the square root of 6. Subtract 2 on both sides, and I'm left with negative 2 plus or minus the square root of 6. All right, I hope you enjoyed. Thank you for watching A Heise Creation. Have a nice day. Bye-bye.